Alright, gang. Let's tie this whole section together. Let's do some examples. Alright, and so what we're going to do the leading coefficient test to get the left and right hand behavior. We're going to find zeros. We're going to use the intermediate value theorem if we need to get some ideas on where it might cross the x-axis. We're going to tie it all together right here, right now, for your entertainment only. So here we have an equation. 2x to the third minus 6x squared. Now if you want to find the zeros, the quickest, easiest way to do it is to start by factoring. So let's factor this. Oh, no, I'm sorry. Again, I'm getting ahead of myself. Let's do the left and right hand behavior. The leading coefficient test. Okay, we have an odd power and a positive coefficient. What exactly does that tell us? It tells us that it's going to look like that. All right, now let's try to work at those zeros. Let's factor this beast. 2x squared can be pulled out, and I'm left with x minus 3. So that tells me what? It tells me I have a 0 right about there and there. And we also know that because of the multiplicity, we know that it's going to touch without crossing at 0, and that it's going to cross at 3. At 3. All right, now think about this. Those are the only places where it touches or crosses the graph. So if it crosses right there and it has to be going up, we know that it's going to look like this. And it touches here, we know roughly that it's going to look like that. All right, so we're going to use the intermediate value theorem. No, we're not going to. What we're going to do is figure out where that bottom of the graph is. How can we do that? Well, I'd like to make it easy on us. So I'd like to test point 1 and 2. And maybe that'll give us a good idea what that graph is going to look like. Plug that into the original function and see how far down the graph goes. All right, so f of f of 1 is negative 4. So that's going to give us a point right there. F of 2 is negative 8. It's going to give us a point right there. And I think it's kind of helpful if during the process of making your graphs you actually make that sound effect. Once again. Alright, there we go. Now we know enough to graph it. There we go. There's our graph. All that because of just a few things that we learned in this section. Next example. 3x to the fourth minus 4x to the third. All right, we have a fourth degree positive. What does that tell us? It tells us this. What should we do next? Look for the zeros. Factor this thing. We can factor out an x to the third. And that tells us a few things. It tells us we have a 0 at 3 and at 4/3, and the multiplicity tells us even more. Okay, we have those 2 points. At 0, it crosses. At 4/3, It also crosses. So none of these are touching at those 2 points. All right, so we could be dealing with a few different things here, so we're going to have to test a few points. The graph could look like that. The graph could look like that. So we're definitely going to have to get more information to figure out what this is going to look like. All right. Because this combines both degree 4 and degree 3, it likely will not be symmetric. I'm not comfortable only testing 1 point, so I'll test 2 points, one of which will be unavoidably a fraction. All right, I would probably test even more points than I'm doing in this example. All right, so what should we test? Let's test 1/2. Okay, why the crazy number? Because this is 0 and this is 1. The only thing in between 0 and 1 are fractions. That's a drag, but it is what it is. We're in pre-calculus because we're pretty doggone smart. I think we can figure it out. So you plug in 1/2, and I used 1/2 because that's one of our easier fractions to work with. I get negative 5/16, which is roughly a third. I'll try 1, and I get negative 1. And so that's enough to give us a rough idea of what this thing is going to look like. It's going to look like that. All right. You can never test too many points in between things. It's always a good idea to test, a few points. We're trying to get ourselves in a position where we're smart enough that we don't have to test a whole bunch of points. The whole point of learning all these graphing techniques is so that we don't have to plug and chug all the time to figure out every little coordinate. But when it comes to finding these dips or those peaks for these asymmetric graphs, always use a few points. All right, let's try one more. Oh yeah! Oh yeah, insert maniacal laugh here. Yeah, this is beautiful. Look at all those wonderful fractions. Well, we can do the leading coefficient test right out of the gate. We don't need to do anything fancy to do that. We have a 4th degree polynomial with a negative coefficient. So that tells us all right, super. Now, I know you guys don't like fractions. Is there anything that we can do to help us sidestep these fractions? And don't say decimals. Decimals are even worse than fractions. Well, if you look at that, you have a denominator of 4, a denominator of 2, a denominator of 4. My goodness, I could factor out 1/4. A negative 1/4. And in fact, I can factor out a negative 1/4 x squared. Why negative 1/4? Because then negative 1/4 times 1 goes there. Well, this happens to be 6/4, right? So multiply 1/4 by 6 to get that one. Actually negative because I pulled out a negative 1/4. And then I can do a plus 9 right there. Ooh, that looks good. Let's factor out a negative 1/4 x squared. And that's what we get. And if you look, even that parenthesis can be factored yet. This is fantastic. Look at that. I have two zeros, both of even multiplicity. This is going to be a piece of cake to graph. So keep this in mind. You had this utter nastiness, negative 1/4, 3/2, negative 9/4. And look at how nicely it factors out. And how nicely it's going to graph, because there's a 0, it touches without crossing. There's a 0, it touches without crossing. Look at that. Now the only thing that we have left to do is figure out what it's doing in between those two peaks. So we'll test a few points. This one actually is symmetric. It factors into two perfect squares, and for that reason it will be symmetric. So let's try a few points in between. 1 and 2. Yeah, those are both good points, but I think because I know it's symmetric, it's going to be at its very bottom, halfway between. So I'm going to have to test that point right in between 2, which would be 3/2. All right, let's do it. And yeah, because of all the nastiness of the 1/4 and all that other stuff, then it might be easier to use the factored version when you try to plug and shove and get those points. So plugging in 1, f of 1. Okay, when I plug 1 in, right there I get a negative 2. When I plug a 1 in right there, that's just 1. So I have negative 1/4 times negative 2 squared. Negative 2 squared is 4. So I end up with a negative 1. All right, let's plug in 3/2. A bit nasty, but again, something we're completely capable of figuring out. Ends up being negative 1.27. And lastly, let's plug in 2. F of 2 gives us a negative 1 again. There's the symmetry I was talking about. So the graph is going to look like this. All right, so those are some good examples for you to kind of piece together everything that we've done in this section. Adios.